So students, today's our topic is mole concept. In this video, you will learn why the value of 1 mole is 6.023 into 10 to the power 23. Why not any other value? What is atomic mass? What is the unit of atomic mass? And why the volume of 1 mole of gas at STP is 22.4 liter. In this session, we are going to understand mole concept on the basis of some important questions or in the form of questions. So, mole concept, let us start with mole concept, and to understand mole concept, first we will understand an atom. Atom is the smallest fundamental particle, and atom consists of three particles: electron, proton and neutron. In atom, there is proton and neutron present in the nucleus of an atom, and electron revolve around it. The sum of proton and neutron present in the nucleus of an atom is called atomic mass, and the number of proton present in the nucleus of an atom is called atomic number. Now, what is the unit of atomic mass? To understand mole, we have to understand the unit of atomic mass. It is very important. The unit of atomic mass is AMU, atomic mass unit. This is the smallest unit of atomic mass. 1 AMU is equal to mass of 1 proton. Mass of 1 proton is equal to mass of 1 neutron, that is equal to 1 AMU. AMU is smallest unit of mass, that is atomic mass unit. So, in day-to-day life, we cannot see atom. We cannot see molecule because these are very small particles. It cannot be seen by our naked eyes. So, to understand mole, we have created a group. Suppose one atom cannot be studied by our day-to-day understanding, or one molecule cannot be studied by our day-to-day understanding because it is not seen by our naked eyes. So how can we understand an atom to other people? One atom cannot be seen by or studied by an individual, but a group of atom can be studied or which is visible, and that group is called 1 mole, and 1 mole is 6.023 into 10 raised to the power 23. 1 mole is a quantity. 1 mole means 6.023 into 10 raised to the power 23. This much atom, this much molecule, this much ion, this much electron, and this term is also known as avogrado number. Avogrado number. So this value is fixed for an atom. This is avogrado number. So why this value is taken as 1 mole? Now understand the mass of 1 proton. The mass of 1 proton is the smallest mass. It is quanta of mass. The mass of 1 proton is 1 proton, 1 neutron, 1 AMU is equal to 1.67 into 10 raised to the power minus 27 kg. This is mass of 1 proton, 1 neutron or 1 AMU. I am going to explain you that why the value of 1 mole is 6.023 into 10 to the power 23. The mass of 1 proton is 1.67 into 10 to the power minus 27 kg. Let us understand with one question. Suppose I have started collecting protons, and I have collected around 1 gram proton. Now, how many protons I have been collected? Question is, how many protons will together weigh 1 gram. Why we are asking for 1 gram? Because 1 gram can be measured easily. We cannot measure microgram, nanogram. We can physically measure 1 gram, 2 gram, 4 gram, 10 gram. We can use in day-to-day life by gram. You are doing experiments in chemistry, there is a mass in gram. 5.6 gram of oxalic acid, 2 gram of oxalic acid in 250 ml of water. These type of calculation you have seen in your lab experiments. So there are experiments in gram. So we want atomic or molecular mass in gram so that we can understand it easily. And this much particle, 6 into 10 raised to the power 23, this much particle ranges in gram. How many protons will together weigh 1 gram? So there is total mass is 1 gram and mass of one proton is 1.67 into 10 raised to the power minus 27 kg. M total mass is equal to N number of proton and MP is mass of one proton. N is number of proton. We have to find how many protons, means number of proton. And mass of proton is 1.67 into 10 raised to the power minus 27 kilogram. And total mass that I have been collected is 1 gram. So this is in kg and this one is in gram. Convert both of them in gram. This one is in gram. Convert mass of proton in gram by multiplying 10 to the power 3. Now this is also gram and this one is also gram. Now we will find the number of proton. 1 divided by 1.67 into 10 raised to the power minus 24 n is equal to 10 raised to the power 24 upon 1.67. We can also write this 10 into 10 raised to the power 23 and 1.67 is 6.023 into 10 raised to the power 23. This is avogrado number. Now understand why the value of 1 mole is 6.023 into 10 raised to the power 23. The mass of one proton is this much and 1 gram proton has value of 1 mole. It means 1 mole proton has mass of 1 gram. And there is nothing smaller than proton in terms of mass. I will not say half proton, 1 by 4 proton, 2 by 3 proton. Proton is quanta of mass. Smallest unit of mass is proton and neutron. So, anything which has mass is in terms of proton and neutron because it is the smallest quanta of mass. The value of 1 mole is 6.023 into 10 raised to the power 23. This means this much proton weighs 1 gram. So, scientists have decided the value of 1 mole is 6.023 into 10 raised to the power 23. This value is large enough. 6.023 into 10 raised to the power 23. Ones, tens, 100,000, 10,000, lakh, 10 lakh, crore, 10 crore, arab, 10 arab, kharab, 10 kharab, null and nil. The counting finishes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Still, 6 zeros are left. When value of 1 mole is very, 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 very large. And atom and molecules are very small. So, the value of 1 mole is 6.023 into 10 raised to the power 23. Now, understand the another concept of mole, that is atomic mass. Atomic mass is sum of proton and neutron present in the nucleus of an atom. The sum of proton and neutron present in the nucleus of an atom is atomic mass, or 1 AMU. I can write 1 AMU in a different way. This different way is 1 AMU can be 1 gram per mole. Now understand the unit of atomic mass. You have to learn that the value of atomic mass is unit of atomic mass is gram per mole. Now what does this signifies? 1 gram per mole, this means 1 mole proton has mass of 1 gram. Gram per mole means for 1 mole. For example, if somebody says energy is kilojoules per mole, so it is for 1 mole molecule or 1 mole atom. Per mole means for 1 mole. So 1 mole proton has mass of 1 gram. What is the atomic mass of carbon? Carbon has atomic mass of 12 AMU. But do not use AMU. If you want to understand mole concept, forget AMU. Learn gram per mole. Carbon has mass of 12 gram per mole. Again, we are going to understand what is gram per mole. Carbon has mass of 12 gram per mole. This means 1 mole carbon atom has mass of 12 gram. 1 mole carbon atom has mass of 12 gram. This means 6.023 into 10 raised to the power 23, this much carbon atom has mass of 12 gram. This much carbon atom has mass of 12 gram. So, 1 carbon atom has mass of 12 divided by 6 into 10 raised to the power 23 in grams. So it is around 2, less than 2, 1.9 into 10 raised to the power minus 23 gram. This is mass of 1 carbon atom in gram. This is very, 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 very small. So we can also find the mass of 1 atom in gram. So 1 mole carbon atom has mass of 12 gram. So this is the unit of atomic and molecular masses. For example, we have CO2. Carbon is an atom, oxygen is an atom. Atom combines to form molecule. Now carbon has mass of 12 and oxygen has mass of 16. 16 into 2, 32. Then the total mass is 44. Now this is molecular mass and unit of molecular mass is gram per mole. Never forget that the unit of atomic and molecular mass is gram per mole. Now understand mole again. If weight of any substance is given, we can find moles. And if we can find moles, we can also find their particles. Whether it is atom, molecule, ion, electron, we can find that quantity. So for CO2, the mass is 44 gram per mole. What is the unit of mass or weight in chemistry? In chemistry, we are doing experiment in lab. We will do in the form of gram, not in the form of kg or milligram. That is easy to calculate, easy to weigh. That is gram. So the unit of mass or weight is same in chemistry, and this is gram. Now what is the unit of atomic and molecular mass. The unit of atomic and molecular mass is gram per mole. Atomic mass or molecular mass as unit of gram per mole. Just divide these two quantities, mass upon atomic mass or weight upon molecular weight. Divide these quantities, you will get mole. We have just divided unit from unit, unit and dimension, class 11th physics. Gram to gram is cancelled and this value is mole. So the formula of mole is weight divided by molecular weight, weight divided by atomic weight. That is equal to 1 mole. It is not a formula. It is just division of unit with other unit. The most important thing, the unit of atomic mass or molecular mass, that is gram per mole. So now mole is weight divided by molecular weight or weight divided by atomic weight. Now mole is weight divided by molecular weight or weight divided by atomic weight. This is mole. Let's do one question on it. How many atoms of carbon are present in 6 gram of graphite? So graphite is a allotrope of carbon, diamond is allotrope of carbon, coal is carbon. So yahan this is how many atoms of carbon are present in 6 gram of graphite. We have given the weight. Unit of weight is gram, unit of weight and mass is gram. Now graphite is carbon. You have to learn the atomic masses of element 1 to 20. That is most important thing to understand or solve the numericals on mole. Carbon has atomic number of 6. 6 is even, just double, so that comes atomic mass. Carbon has atomic number of 6, then mass number is 12 and unit is gram per mole. Weight is 6 gram and atomic weight, this is atom, is 12 gram per mole. Now we will find mole. Mole is weight divided by atomic weight. Weight is 6, molecular weight is 12. Now mole is 1 by 2. First find mole. So 6 gram graphite means half mole. 1 mole has particle of 6 into 10 to the power 23. Then half mole has particle of this much. So the number of atom is 3 into 10 to the power 23 carbon atoms are present in 6 gram of graphite. Now another question. Why the volume of 1 mole of gas at STP is 22.4 liter? Any gas, it can be oxygen, it can be helium, it can be nitrogen, it can be ammonia, but its volume at STP, STP means standard temperature and pressure. Standard temperature is 0 degree centigrade, 273 Kelvin, and standard pressure is 1 atm. At this temperature and pressure, volume of 1 mole of any gas is 22.4 liter. We are going to prove this. For proving this is to, we have to learn one gas equation. PV is equal to nRT. This is ideal gas equation. You will learn it in chapter 5, states of matter. And gas is one of the state of matter, and this is gas equation, ideal gas equation. PV is equal to nRT. So question is, prove that 1 mole of gas at STP has volume of 22.4 liter. We have to prove this, that 1 mole of gas at STP has volume of 22.4 liter. STP, standard temperature. Standard temperature is 0 degree centigrade or 273 Kelvin, and standard pressure is 1 atm. So pressure is 1 atm, and we have given moles. This is mole of gas. R is gas constant, and the value of gas constant is fixed 0.082 liter atmosphere per Kelvin into mole. This is value of gas constant. And temperature, we have to put temperature in Kelvin. Now 0 degree centigrade temperature is 273 Kelvin. Mole is 1, R is 0.082, temperature is 273, and pressure is 1 atmosphere. So the volume becomes 1 into 0.082 into 273. It is around 22.4 liter. So volume of 1 mole of gas at STP is 22.4 liter. We have proved this according to ideal gas equation. Now we know two things about mole. One, that the value of 1 mole is 6.023 into 10 to the power 23. This much particle. It can be atom, molecule, electron, ion, or anything. And the second thing we know about mole is the volume of 1 mole of gas at STP is 22.4 liter. Now these two information we will use to solve the numericals of mole. How to do numericals on mole? This is the easiest way to solve numerical of mole. I am writing one simple formula here. Let's understand that formula. Mole is weight divided by molecular weight. Volume divided by 22.4 at STP, and number of molecule divided by Na. Na is Avogadro number. Take Avogadro as 6. Use 6 into 10 raised to the power 23 for calculations. This is the final formula for our mole. Weight divided by molecular weight. Molecular weight you can find. You can find by yourself, such as for CO2. CO2 is 44, O2 is 32, N2 is 28. Glucose. Learn some molecular weight such as glucose. C6H12O6. Glucose has mass of 180 gram per mole. For example, sucrose. C12H22O11. Sucrose, cane sugar, table sugar, it has mass of 340, molecular mass of 342 gram per mole. NaOH, Na is 23, oxygen is 16, hydrogen is 1, that is equal to 40 gram per mole. So these are molecular masses. So the lower term In the three cases, we know the denominator. Molecular weight we can find likewise. 22.4 is fixed. At STP, the volume of 1 mole of gas is 22.4. This is fixed. The number of molecule for 1 mole, this is also fixed. That is 6 into 10 to the power 23. Now, the question will ask weight and it will give volume. If it will ask volume, it will give number of molecule. So in these three things, it will give any one and ask other one. For example, if weight is given, molecular weight can be found by this technique or this way. If weight is given, you have to find volume. If weight is given, it can ask for molecule. Molecule, if you find molecule, then you can also find atom or further smaller particle, electron, proton, neutron. This also can be found by this way. First, you have to find mole. Mole is a bigger term than molecule, and here you can go for two ways, atom or electron. Now we are going to discuss some important questions on mole concept. Write this formula for solving numerical. In these, this will be given and this will be asked. Let us understand with some example. Question is, calculate the volume of 11 gram of CO2 at STP. The first step to write formula. The formula that I have told you, write it here. Mole is weight divided by molecular weight, volume divided by 22.4, and number of molecule by Avogadro number. Put the values here. You have given 11 gram of CO2. So, weight is given and it is asking for volume. To apply this portion of formula. Weight is given, that is 11 gram. Molecular weight of CO2, 12 plus 32, that is equal to 44. So 11 by 44. So weight is 11, molecular weight is 44. That is equal to volume divided by 22.4. 1 and 4. Multiply 22.4 here. So 22.4 divided by 4, that is equal to volume, or this is 5.6 liter. The volume of 11 gram of CO2 at STP is 5.6 liter. Likewise, you have to do all other questions on mole concept. Simply learn just this formula. One more question which cover all the aspect of mole concept. In 1.7 gram of NH3, calculate first mole, molecule, atom, volume at STP, and total number of electron. There is nothing smaller than electron. And after electron, no other thing is left to find in an atom. So these are all different types of question based on mole. Very important question. By this single question, you can understand complete mole. Now, ammonia. What is the mass of ammonia? Most important part, the molecular mass and its unit. Nitrogen has mass of 14 and hydrogen has mass of 1. 3 hydrogen are present. That is equal to 17 gram per mole. So, the weight of ammonia, mole is weight divided by molecular weight. The weight is 1.7 gram and molecular weight is 17. So, mole is 0.1. So, mole is 0.1. Now, molecule. One mole has 6 into 10 to the power 23 molecule. 1 mole contains avogrado number of molecule 6 into 10 to the power 23. So 0.1 mole will contain 0.1 into 6 into 10 to the power 23. Cancel it. This is equal to 6 into 10 to the power 22. This much molecule are present in 1.7 gram of ammonia. Now number of atom. The molecule are 6 into 10 to the power 22. In one molecule of ammonia, there are 4 atoms are present. So the total number of atom present in this much molecule is into 4. 1 atom of nitrogen, 3 atom of hydrogen, total is 4 atom, and this much molecule contain this much atom. That is equal to 24 into 10 to the power 22. Now another, find the volume at STP. Mole is 0.1. 1 mole gas has volume of 22.4 liter at STP. So 0.1 mole has volume of 2.24 liter at STP. Total number of electron. How many molecules we have? We have 6 into 10 to the power 22 molecule. This much molecule. Now, how many electrons are present in one molecule of ammonia? Ammonia is NH3. Nitrogen has 7 electron. It has atomic number of 7. The number of electron and proton in an atom is similar. That is why an atom is neutral. 7 plus 3, so 10 electron. So one ammonia molecule has 10 electron. So the total number of electron in this much molecule, one molecule has 10 electron. This much molecule has this much electron. That is Avogadro number 6 into 10 to the power 23. Likewise, you can solve the numerical of mole concept.